On to Logic World. Logic World is slightly, it can get difficult. Okay, there's weird things that happen with logic, and sometimes it does make your brain hurt a little bit with the different things. Not overly difficult. There's one thing we do truth tables on. We'll start those on Thursday, actually. A lot of you don't like those, but once you kind of see the pattern and how they work, they're not too bad. But today we're just kind of introducing logic. Okay, so a logic, we are trying to determine if things are true or false in different scenarios and things like that. But we got to start with the basics and the definitions and all the different things there. So I'll leave this up here for you to write down. But the first thing is a statement. A statement is a sentence that can be proven true or false. Okay, so it can't be a question. It can't be subjective. It can't be anything like that. It can't be a command. But the statement, you have to determine if it is a statement, if you can prove it true or false before you start to move into the logic world on it. Okay, they have simple versus compound. A simple is basically where you have one statement, sentence, where you can tell whether it's true or false. In a compound, you have more than one. I should probably put two or more there, because technically, okay. Technically, it doesn't have to be two. It could be two or more. So a compound, they combine them with these different symbols and different things. The symbols and the ideas of this is kind of relates to sets. So they use, thank you. They use P and Q for the statements. They use R if they use the third one. But I don't know why they just use P and Q a lot for these statements. So if we add a statement, it is Tuesday. That is a statement, like we can prove, like whether it's or we can say it's true or false that it's Tuesday, right? And our Q, it is cold. Like again, you can kind of say, I know that's a little subjective, but it's cold today, so it was the first thing I thought of. It is. You can say that's true or false, like it is cold or it's not cold. Okay. All right. So our symbols here. So for our apostrophe, our complement, they use the not P. They use a squiggly line in front. Okay. Some English person can tell me what that actually is, but it's a squiggly line to me. So squiggle P means not P. So you would just put a not in the statement. It is not Tuesday when you see the squiggly line. If you remember from Sets World, the intersection and the union, the U and the upside down U, and here they use like a little V. Okay, so the V is the or, and then the upside down one is the and. So in both sections, the upside down one is the and the regular looking one is the or. Delete those. So okay. So if you have this symbol right here, you're thinking and you combine it here. This would be a compound statement. They call this the conjunction. The conjunction means that you can prove they both have to be true to be true. So P and Q would be it is Tuesday and it is cold. Okay, it is Tuesday and it is cold. And again, there is one topic at least where it says conjunction, where you have to choose whether it's a conjunction or disjunction or conditional or biconditional. You have to choose those fancy words. But conjunction, again, we'll talk more about whether these are true or not on Thursday. But this is the and. They're both going to have to be true for the whole sentence to be true. Yeah.
It's called a tilde.
It's called a tilde? Is it? Okay. I probably could have thought of that and got that. Thank you. If I'd have thought long enough there, a tilde. Yeah. So squiggly line is tilde. Fancy word there. The V is my or. So you see this symbol, that means P or Q. So it is Tuesday or it is cold. This is a disjunction because technically only one or the other has to be true for the whole thing to be true. So it's not connected because, that's the way I kind of remember. It's not connected because you only have to have one of them to be true for the whole sentence to be true. So I could say it is Tuesday it is Tuesday or we're not going to have class, okay? So we're obviously having class, so that's not true. But the whole statement is true because it is Tuesday, and they only have to have one or the other be true. Which again, we'll talk more about like the truth values on these when we get to Thursday. I didn't think I was going to have to go over these today, but one of the topics does mention these briefly. If I need to go back down, that's fine. But the arrow, if you see an arrow, this is a conditional statement. This is an if-then statement. So the arrow does go in the middle, even though it's like if comes before. But this means if P, then Q. Okay, so this is a conditional statement. Q only happens if P happens. So if it is Tuesday, then it is cold. And again, some of these make sense and some of them don't. But this, I just was making sentences up off the top of my head. So the arrow means if then. Again, we're not going to go too far into the truth values on these. Today we'll do a lot of that on Thursday. I don't even know how far we go into the truth value on if then, the biconditional. The double arrow is if and only if. This is biconditional. So when you see the double arrow, that means P if and only if Q. This one works both ways. That's saying it is Tuesday if and only if it is cold. So it's got to be Tuesday to be cold, and it's got to be cold to be Tuesday. Whereas the if then just says it has to be Tuesday to be cold. So the only thing you got to really know right now is you will run into these symbols, these three symbols, the tilde, the conjunction and disjunction, and then those words over there to identify when you see biconditional, it's if and only if, or if you see or, it's the disjunction. That's the only thing you see right now. And then one last thing, and just while I'm on this page, and then we'll go work some problems, is the negation of a statement. It sounds easy, but it gets a little difficult. The negation of a statement has to have opposite truth values for all the truth values, okay? So in logic world, if you can find one scenario that proves the thing wrong, then it's wrong. So like negation of a truth value basically has to be opposite both ways. So if it is Tuesday is true, then the negation has to be false. If it is Tuesday is false, then the negation of that statement has to be true. Okay. So it has to be opposite in all scenarios. Let's see if anybody's still writing real quick. All right, let's go look at some problems. So identifying a statement, open your presents, that's a command. You can't prove that true or false. These pants are black. Yeah, you can say whether that's true or false, right? How many units do you need to graduate? That's a question, so there is no true or false there. The lion is a type of tree, even though that's silly. Like you can prove whether that's I don't think there's a tree named lion. I don't know, I guess there could be, but even though it doesn't make any sense, like you can prove that true or false. And then this is technically a math statement. 17 minus 5 equals 12. It doesn't matter if that's true or false. Like we're not determining if it's true or false, we're determining if it is a statement, and that is a statement. Okay. Did I click yes on the open your present one? I feel like it just switched on me. Just make sure that is correct. Open your presence command, so that's no. Answer like yes, no, yes, yes. Okay. To identify a simple or compound statement, this is where you're going to have to use those words. Maybe. I feel like the internet has been slow everywhere I go today. So on this one, I will get coffee if and only if I want to stay awake. So the first thing to determine if it's simple or compound, if there are two or more things in the sentence that you can prove true or false, then it is compound. So I will get coffee, so I can either get coffee or not, so that's true or false, right? I will stay awake. That could be true or false as well. So there's two, so that you know it's compound, and then you have the if and only if, so that makes it a biconditional, okay? Biconditional, we don't talk about a ton in this class, but basically that's saying it works both ways. If I get coffee, then I'll stay awake. If I stay awake, then I had coffee. All right, January is my favorite month of the year. There's only, I guess you can still prove that true or false, even though it's a little subjective there because it says my favorite. You're not trying to prove somebody else's. But there is only one thing to prove true or false there, right? And simple. Okay, Sam is running laps and Dan is doing pull-ups. So again, you got two things that you're proving true right here. Is Sam running laps or is Dan doing push-ups? So two separate things. This is compound and this is going to be a conjunction because it is and. They both have to be true to be true. Just to do one more, just to see. No, let's not do that one. I guess so, that's fine. The car will start or the battery is dead. Again, you got two different things. They could be proven true or false. It's or, so this is disjunction. Tom's favorite band is releasing a new album. That's just one, so that's simple. And then we already did an if and only if one. That's biconditional. If and only if. I thought there was one more scenario that I wanted on this. So I ride my bike to work if my car is in the shop. So this is a compound statement. You can ride your bike to work or not, right? You can prove that true or false, and then your car is in the shop, true or false. Even though it's not if then, it is a conditional statement because you still have I ride my bike to work if my car is in the shop. So if your car is in the work, or car is in the shop, then you would ride your bike to work. Okay, so you can reword those a little bit. Oh, this is a good one to do for both of these, actually. Okay, I went ahead and solved this so you can see. But the tractor is red and shiny. This is a compound statement because it could be red, and then that's one statement, true or false, or it could be shiny. That you can prove shiny, true or false, right? But the second one, just be careful with this. Just because it has the word and in it doesn't mean it's compound. My favorite sandwich type is peanut butter and jelly. Okay, is my favorite sandwich peanut butter and jelly? That peanut butter and jelly is one thing, right? That's just the name of the sandwich. So just because it has an and or an or in it doesn't mean it's automatically compound. Like this, I'm still only proving is my peanut butter and jelly my favorite sandwich, true or false, right? So that is a simple one. All right, negation. Negation starts to get a little weird here. We'll get to the hard topic in a second. But with negation, for it to be a negation, all of the truth values have to be opposite. Okay, so when this is true, the negation has to be false, and when that is false, the negation has to be true. So x is equal to 400. So we'll go through each scenario here. X is equal to 400. So if that's true, then x is equal to 500 would be false, right? Okay, but if this is false, if x is equal to 400 is false, that just means it's not 400, right? Does that mean that x is equal to 500? That could also be false, right? What if x is 300? They would both be false, and since they would both be false, this is not a negation. Does that make sense at all? This is where logic starts to hurt your brain a little bit, okay? X is equal to 400, x is not equal to 400. This is a negation, right? Because if that's true, if x is equal to 400, this would be, wait. Yeah, sorry. Why did I confuse myself? Anytime you have the same sentence with like the not in it, it will be the negation. Like that's obvious opposite because it's always equal to 400 or it's not equal to 400. There's only two options there. So that is a negation of that. Now I'm trying to think of why I confused myself on here.
Okay.
Sorry. Why is my brain breaking right here? If x is equal to 400, if that's true, y'all help me think about this. X is not equal to 400. Oh, that would be false, right? See, you just overthink these things and you just get all messed up in your head. If x is equal to 400 is false, then x is not equal to 400, that would be true. Okay, my goodness, I made that way harder than it was. I'm sorry. Sometimes y'all see these real quick and then I talk too much and you know. All right, the next one, x is equal to 400 is, so this was no, this is yes. X is not equal to 500. If X is equal to 400, that's true. That means X is not equal to 500. That would be true as well, right? So that's going to be a no because they're both true right there. The last one, if X is equal to 400 is true, it is not the case that X is equal to 400. So that would be false. And then you can do the opposite. If X is equal to 400 is false, then this would be true. It is not the case that X is equal to 400. So that'd be yes. Okay. This one's not bad because it's very easy to tell. It gets a little harder when they put the not in there. If it is not Wednesday, so if that's true, it is Monday. Would that necessarily be true? No, because it's not Wednesday. What if it's Thursday, right? It is not Wednesday, and it is Wednesday. Anytime they're flat, just have a not difference. It is going to be a negation. If it is not Wednesday is true, then this has to be false, and if that's false, this has to be true. It is not Monday, so if it's not Wednesday is true, well, what if it is Monday? Because that would hold true, and this would be false. But if it's, I guess you got to do the other way. If it's not Wednesday is false, then it's not Monday. It could be Monday there. So this is where it gets confusing on these. This one, like I said, is pretty easy because it's always just, your answer is always just the opposite. So this is not, so my answer is, it is Wednesday. It is not Wednesday. It is not the case that it is Monday. So this is the same thing. It's not Monday. It's not the case. So that's no. Okay. But your answers on these, one more time, just to make sure, because I messed that one up, are always going to be, damn, that's not the one I wanted. Okay, I'm not drawing a rectangle, so I am drawing a rectangle. I thought there was... There it was, and I clicked the button. Here, this will work too. So Shin is wearing tennis shoes, so the negation would be Shin is not wearing tennis shoes, and it would be it is not the case that Shin is wearing tennis shoes. Like, those are the two negations that are here. So really, you're just looking for the not on these. This one's pretty easy, but that whole truth value thing is going to come in handy a lot here in a minute. All right, quantifiers. Quantifiers are where they start to quant is the word there that's a count, so they start to do an amount of those. So you have none, at least one, some, every, all, words like that are quantifiers. This one's not bad. You just have to think through it. No tree in the row has leaves. That's false. At least one tree in the row does not have leaves. That's true. Some trees in the row have leaves. That is true. In math, the word some means at least one. They kind of mean the same thing because as long as one has it, you could say that some have it. No tree in the row has leaves. That would be true. At least one tree in the row does not have leaves. That would be true. Some trees in the row have leaves. That would be false. Okay. No tree in the row has leaves. That's false. At least one tree in the row does not have leaves. That would be false. Some trees in the rows have leaves. That would be true. Okay. So really, this one's not too terrible. It's a little tricky, but you just got to read them carefully and make sure and know that some is at least one. All right. So this is probably the hardest one from today for sure. We'll do it once and I'll show you the cheat code. Is that you combine the negation and the quantify, okay? Again, if you can think of one scenario that can make it wrong, then it's going to be wrong, and their truth values have to be opposite. So I'll go through each one. Every door in the building can open. Every door in the building can open. Let's say that's true. Not every door in the building can open. Well, that would be, if I say every door in the building can open is true, then not every door in the building could be false, right? Okay, what if it's false that every door in the building can open? Then it would be true that not every door in the building could be open. So that's yes. So again, when you just do the not of the same exact thing, that one's easy to tell that it's a negation, okay? All right, every door in the building can open is true. So at least one door in the building can open. That would be true, right? If every door opens, then at least one of them's got to open. So since they're both true, that's a no. They would not be a negation. They have to be opposite. Every door in the building can open. If that's true, none of the doors in the building can open. That would be false, right? And if every door in the building can open is false, this is a tricky one. Would none of the doors in the building can open be true? Not necessarily, because if I say every door in the building can open is false, well, what if 9 out of the 10 can open? That statement's still false, but this would also be false because that says none of them, okay? So every door in the building can open is true. Some doors in the building cannot open. That would be false. If that was true, that would be false, right?
Yeah.
So if every door in the building can open is false, then some of the doors in the building cannot open. That would be, I feel like that's true. I gotta click solve here. That would be true, right? If every door in the building can't open, then some of the doors cannot open. As long as it's one or more, we're good. So yeah, that would work. Okay, here's your cheat code on this. And you can take a picture now or later. But this little chart, if this really hurts your brain, and it hurts my brain sometimes too, as you saw me confuse myself a minute ago. These are the words. And I know it's hard to see these. They're working on making these accessible via like screen reader, so they keep changing stuff, and I need to tell them that you can't read that. So these are keywords in the statement, and these are keywords in the negation. So if you say all or every, the negation words for that are some, cannot, at least one cannot, not all, and not every. Okay? The opposite of no or none would be some or at least. This is one of those, I talk about this in stats class, but I don't think we need it in this class. The opposite of some, the opposite of none is actually at least one. Because that's all the possible options. You got none, and at least one would cover everything else. So those are, and these right here are actually just the first 2 rows flipped, so you really don't even need those because that kind of works that way. So you really just need those first 2 rows. So that is what you were looking for negations. If you really struggle with these and it's hard to think about them, because some people's brains just don't work like that. Sometimes my brain doesn't work like that sometimes. This chart will help you get through this topic for sure, and we'll deal with it more if it's on the test. Let's do one more just to make sure. All right, so if you went to the chart, some members of the club can vote. The opposite of some does it have that on the chart? I took a picture of the chart last class, so I'd have it. The opposite of some is no or none. The opposite of some is no or none. Okay, so some members of the club can vote, some members of the clubs cannot vote. That would obviously not be a negation because they can both be true at the same time. Some members of the club can vote, no member of the club can vote. That would be a negation because no is the complement of at least one. Like, if that's true, some members can vote, then this would be false. No members can vote. And if that's false, some members can't vote, then this would be true because if some members can't vote, then nobody can vote, right? All right, all members of the club can vote.
Yes.
That's a yes. Remember, some is at least one or more.
Okay.
So some could be all of them, technically. Some is like at least one. So this would be no, because if I say that's true, this could also be true. Not all members of the club can vote. I feel like that's a yes as well because, oh no, that's a no. Oh, not all. I'm sorry, not all. This would be false because if that's true, some members of the, if that's true, this could also be true. Because this is saying everybody should get a vote. Not all can vote. So again, if you get stuck on those, use the chart there. All right, the last one's not bad. It is just taking those statements and putting them into symbols. Okay, so it is cloudy is P. Reuben is wearing a coat is Q. So you just say Reuben is wearing a coat Q, and would be the upside down one. It is cloudy, so P. It is not cloudy, so that would be not P. Okay. Q this would be the regular looking V is Q or P. So Q is Ruben is wearing a coat, and I'm looking for or, so it's that one. It's not the one above it because that has a knot in it. So Q is Ruben is wearing a coat, or it is cloudy. Okay, so that one's not too bad. The SUV is on the road. Q is the layer of snow is below us. Did I hit a button? Yeah. The SUV is on the road. That is P. Or a layer of snow is not below us, so that'd be not Q. Okay. A layer of snow is not below us, so that would be not Q. But the SUV is not on the road. When they use but, it is the same thing as and. I need to double check that. It is. Okay. I want to make sure, but yes, a but is the but it signifies that they both are happening. They both have to happen for the statement to be true. So layer of snow is not below us, and the SUV is not on the road. Okay. This is the one that I did want to point out, and I know I skipped it right here, but all right, got the answer. This is saying it is not true that Q or P is happening, right? So the parentheses signify that I need to use a quotations on here because I'm saying it is false that everything inside the parentheses, okay? So you will use a quotation on those. So it is false that a layer of snow is below us, or, because it's a V, the SUV is on the road. So when you get a problem, like this first one right here, it says it is false. Well, that tells me to use this. The quotation tells me to use parentheses. So now I can read inside the parentheses. We are having pizza for dinner is P, and it is Saturday. And it is Saturday, okay? So that is what the quotation tells you, is that's a parentheses because you're saying everything inside the parentheses it is false, okay? Or it's not the case that. We'll go ahead and finish this one real quick. It is not Saturday, so that'd be not Q. And we are having pizza for dinner. And then not P or not Q for this one. So we are not having pizza for dinner, or it is not Saturday. Right? We are not having pizza for dinner. This is the not. We are not having pizza for dinner, or it is not Saturday. Okay? All right, so that is the introduction to logic.